In this slide, we're talking about optical principle in torchlight design. Here are our four question banks. First, what is TIR, aka total internal reflection? Second, how TIR is applied in torchlight. Third, our model of torchlight. Fourth, what are the applications of TIR in our daily life?
So, what is total internal reflection? In physics, total internal reflection (TIR) is the phenomenon in which waves arriving at the interface from one medium to another are not refracted into the second medium, but completely reflected back into the first medium. It occurs when the second medium has a higher wave speed, in other words, lower refractive index than the first, and the waves are incident at a sufficiently oblique angle on the interface. For example, the water-to-air surface in a typical fish tank.
The critical angle is the smallest angle of incidence that yield total reflection, or equivalently, the largest angle for which a refracted ray exists. For light waves incident from an internal media with a single refractive index n1 to an external media with a single refractive index n2. The critical angle is given by sin c equal to arc sine n2 over n1 and is defined if n2 small n equal to n1. For some other types of waves, it is more convenient to think in terms of propagation velocities rather than refractive index.
Okay, so now I'm going to show you what is the difference by using the total internal reflection lenses and the reflectors inside the torchlight. Typically, total internal reflection lenses are rotationally symmetrical designs which give a really nice light distribution and can have more control over the light. With the comparison, for the reflector, there is a big part of the light doesn't touch the reflector, and hence the light cannot be controlled in any way, and even there are some light energy can be absorbed by the surface of the reflector itself. Here you can see, by using total internal reflection lens, the light distribution has a sharp cutoff, and the relative intensity of light is much higher with compared to the reflectors. Reflectors produce much softer cutoff even if the viewing angle is same because the light is spread out into a wide angles.
Torchlight. Torchlight were designed for high precision and controlled light delivery. The light emitted by LED enters the optical fiber at angle that undergoes total internal reflection. Total internal reflection. The angle of the incident must be greater than its critical angle. The light travels through the cladding at an angle greater than its critical angle. Light passes through the fiber, allows the torch to project a focused and intense beam.
Total internal reflections in binoculars works through the manipulation of light using prisms. Light entering the binoculars through the objective lens is directed to the eyepiece. The prism inside the binoculars have surface angle in such a way that when light strikes them at an angle greater than the critical angle, total internal refraction occurs. This means that instead of passing through the prisms, the light reflects off the surface and continues its path within the binoculars, eventually reaching the eyepiece. This process ensures that the light is efficiently transmitted through the optical system.
Total internal reflection also used in optical fibers for telecommunications. These fibers are made up of glass or a very thin plastic threads in which light can travel. When the light comes in contact with these fibers and makes an incident angle greater than its critical angle, it gets refracted back into the core of the fiber, and due to this, it can travel up to kilometers without the loss of any ounce of energy.
Total internal reflection occurs in diamond due to the phenomenon of light being completely reflected back into the diamond when it encounters the boundary between the diamond and air at a certain angle, known as critical angle. In diamond, which has a high refractive index, light entering the diamond at an angle greater than the critical angle undergoes total internal reflections, preventing it from escaping and causing the diamond to sparkle. This property is exploited in diamond cutting and jewelry making to enhance the brilliance and sparkle of diamond.
Light waves that reflect from the passageways of the human body and enter the optical fibers in an endoscope travel through the optical fibers with total internal reflection, and the light exits the optical fibers in the same way it entered them. This allows for the transfer of an image for a viewer to examine.